Hello, everybody. We are going to talk about how to graph the derivative from a graph of the function. Now, first thing we got to look for are horizontal tangents. So when I look at this graph right here, I have a horizontal tangent at this point here, and this point here. Now, the reason this is important is that the derivative is the slope of the tangent line, okay? So, horizontal tangents have zero slope. So if I were to draw a tangent line at these points, my tangent line would look like this. They have zero slope, okay? These points are going to act like anchors for the actual graph of the derivative. So what I'm going to do is take these points, and we're going to mark them on the x-axis, because my derivative is going to cross the x-axis at these points. That's where I have zero slope. Second thing they do is they act as partitions. So if I come in here, draw some dotted lines, these partitions are going to mark boundaries of where the derivative changes signs from positive to negative, okay? And remember, derivative is equal to slope, okay? My derivative is equal to slope. So, where my derivative is positive, I'm going to be above the x-axis. So where the slope is positive, I'm above the x-axis. Where the slope is negative, my derivative will be negative and below the x-axis, okay? So positive usually ends up looking like this, and negative ends up looking like this, okay? So what we're trying to do is partition this thing off in positive and negative slopes. So when I look along here, this whole thing is going downwards. Along here, the graph is going up. Along here, my graph is going down. My graph is going up, okay? Where my graph is going down, I'm going to have negative slope. So what I'm going to do is I'm going to shade this thing below the x-axis where the graph was going down, because my slope is negative. My slope is going up here, so I'm going to shade up above the x-axis, because my slope is positive and my graph has to be above the x-axis, okay? In this next spot, I'm going to shade down because my graph is going down again, okay? And then I'm going to shade up because my graph is going up, okay? So there, these mark the areas where the derivative has to be. Now, from here, it's real simple to draw my derivative. All I have to do is stay in the shaded areas and pass through my anchor points where my derivative was zero. So my derivative graph has to be down here, down here, and up here. And I'm just going to end up with something that looks like this. And there's the graph of the derivative. Pretty simple, okay? Now, when we get to things like this is the teachers who have little to no life in them and they want to torment people, okay? Now, this doesn't change the rules. What it does change, though, is the anchor points. I don't have a horizontal tangent in here at all. So what we're going to replace them with are these corners right here, okay? We have three corners right here. Now, if you remember right, corners are where the derivative doesn't exist. And the primary reason for that is the left and right sides are not the same. The slope here is negative, the slope here is positive, so the derivative cannot exist at these corners, okay? So they're going to act like my partitions on this graph, just like they did on the last graph. And I'm going to come in here and draw some vertical dotted lines at these points, because we're going to end up doing the same shading on this that we did on the other one. Now, what's going to be different here, though, is, we'll talk about that in a minute, but there is something different. Right here, my graph is going down. Since my graph is decreasing, my slope is negative, I'm going to shade below the x-axis. Over here, we're increasing, my slope is positive, so I'm going to shade above the x-axis. Down here, I'm decreasing, so I'm going to shade below the x-axis. Over here, I'm increasing, so I'm going to shade above the x-axis, okay? So what we have here now is a picture of where the derivative should be. The derivative has got to stay in the shaded areas, okay? Now, what makes this graph different is it's not curved. That means the slope is not changing from x value to x value. This slope along this line is very constant. This slope right here is -1. So if I'm the uptight anal person, I'm going to have to draw my derivative right here, not there, right here at -1. So my derivative should be right there at -1. Now we're going to put open dots on this thing because the derivative doesn't exist at these corners. If I look at this, it's going up. My slope is rise over run. You get 1. So my derivative should be here. Okay? We're going down here. My slope is 2. So my derivative should be down here at 2. And over here, my slope is 1 again. So my derivative should be up here. Okay? So this purplish color is my derivative. And I'm drawing the lines when y coordinates at 1, -1, 1, -2, 1, because the slope is -1, slope's +1, slope's -1, slope's +1. Now, some of the teachers, when you see these graphs, when they give them to you, they're giving them to you like this. They do not, do not actually give you the y coordinates when they give you the graph. So you would see a graph that looks like this. Okay? Now, if I don't have the y coordinates, there isn't much I can do with it for accuracy. I can't mark -2 for this because I don't actually know what the slope is. So when you graph something like this, all you can do is partition it. This is down. We're going up here. Draw my partition there. We're going up here. We're going down here. And then the only way I can really draw my derivative from here is just some lines. I don't know where they are, so I'm just going to draw a few lines in there like that. Okay? One more of these and I have to quit because I have a 15-minute time limit on these videos. Okay? Now this one is mixing the two things together. All right? So first thing I got to do is find any horizontal tangents. This one has a couple of horizontal tangents. All right? It has one right here. So I am going to have to put a dot right there for this one. Okay? Let's use the right color for that dot right there. There is a physical jump here, so the derivative won't exist at 1, the derivative won't exist at 2. Between 1 and 2 it's horizontal, so I am going to end up with a derivative right there. Now for the rest of this, we have a partition going right down the center here. We're going to have a partition here, and we're going to have a partition here. We're decreasing here, so my derivative's got to be down below the x-axis there. We're increasing here, so my derivative's got to be above the x-axis here. We're increasing over here, so my derivative's back above the x-axis. But right here, my derivative is horizontal, so that line has got to be my derivative. Okay? Now, because this is curvy right here, when I go to draw it, I'm going to draw a curve on it. My curve has to reach up to this 0 slope. Now, I happen to know that this is a quadratic, and the derivative of a quadratic tends to be linear. So instead of drawing a curvy line, I'm going to draw a straight line up to this point here. Now, this point should be open. Okay? Not open, sorry. We just go right through that point. Shouldn't be open, I just go right through the point. These points right here should be open. This is a straight line, so when I go draw my derivative here, it's going to be a straight line. So the pink here is what the derivative looks like. This is a parabola. Parabolas, the derivative of parabolas tend to be straight lines, so I'm drawing a straight line for it. This is horizontal, so I have a horizontal derivative. This is a straight line, so I have a horizontal derivative, but it's not on the x-axis. All right, I hope that helps you with sketching derivatives. I am going to go start working on something else, and I'll be back in a few minutes with something else. Okay? Back in a bit.